Let's see if we can get through this 9.2 homework. Let's make sure we put our name and we put the period, whatever period you're working in. Okay, let's remember from class, rate is equal to slope is equal to speed, which is equal to the constant of proportionality, which is equal to the letter K. All of these things, for some reason, all these old guys in math decided that these should all mean the same thing. So if they ask you constant of proportionality, they're asking you for the rate. Oh, rate of change as well. So no matter what they're asking us one of these. Okay. So what are the important graphical features of proportional relationships? Circle all correct statements. So proportional relationships. Graphical features means what does the graph look like? The graph is a straight line. Yes. The line has a y-intercept of 0. Well, let's take a look. We know that that is what a proportional relationship looks like. Y-intercept, this is your y-axis. Does your line hit at y is 0? Yes. The line passes through the origin? Yes. The line has an x-intercept. Intercept means cross through. So here's your x. Does your line cross x when x is 0? Yes. The line passes through the point 0, 0. So it's a straight line. It's got an x and y-intercept of 0. So it goes to the point 0, 0, and that point is called the origin. All right, use the graph to answer questions 2 through 5. Number 2 asks, which lines represent proportional relationships? Well, proportional relationships always go through the origin. So A, D, and E. A, D, and E, because they go through the origin. Sorry about my handwriting. Origin. All right, find the rate of change for each line. Okay, so for A, we've got, let's make a little mini table. I wish they gave us more room. We know we're going to make a table. So rate of change is the same thing as rate, which is the same thing as slope, same thing as speed. So we're going to pick 2 points on A. First point, 0, 0. Now follow that line up and follow it where it goes right to the corner of one of these boxes. See, it can't be in the middle of a box. It's got to be right on the corner. So that's 1, 4. To go from 0 to 4, I had to add 4. 0 to 1, I had to add 1. So remember, the rate of change is the change in y over the change in x. Y changed by a positive 4. X changed by a positive 1. And so my rate of change is 4. All right, let's try B. B, let's make a little table. All right, let's check B. Well, B, the first point is perfect. It's 0 is the x, y is the 4. Okay, and then the next point, follow B until it gets to a perfect right there. So that would be 7 of the x, and that's 5 on the y. So to get from 4 to 5, I had to have a change of 1, and 0 to 7, I had to have a change of positive 1. So remember, it's the change in y over the change in x. The change in y was a positive 1. The change in x was a positive 1. And so you're making sure to get a 1. Your rate of change, or your rate, is a 1. These are positives, by the way. All right, C. Let's find C. C, here's a perfect point. The x is 0. X is on 0, y is on 2. All right, so follow that line till you get on a perfect corner. There we go. 2 is my x. 3 is my y. Remember, it's change in y over change in x. So the change in y was a positive 1. My change in x was a positive 2. So my rate is 1/2, or 0.50. You'll start to notice that as we get further and further into the algebra curriculum, we start going less decimals, more fractions. So get used to that. We're going to leave slope or rate or speed in more fractions. All right, D. I'm going to do D over here so I have a little bit more space. D, first point, 0, 0. Follow D until you get a perfect corner point. There we go. X is 2. Y is 1. All right, well, it's the change in Y over the change in X. The change in Y, we added 1. The change in X, we added 2. And so our rate, again, is 1/2 or 0.50. So C and D were both 1/2, C and D. Take a look at C and D. What do you notice about those two lines? They both have the same rate, and so they're both parallel. Very good. So they have the same rate. They have both parallel. All right, let's take a look at, last one is E. So let's say this is E. E, first point, 0, 0. Follow E until you get a perfect point right there, which is 7 and 1. So 7 is the X, Y is the 1. Change in Y over change in X. Whoops. Y changed by a positive 1. X changed by a positive 7. And so we get a rate of 1/7 or whatever 1 divided by 7 is. I don't know off the top of my head. Notice that 1 divided by 7 is a very small decimal. The closer you get to 0 on the number line, the flatter the line. Recognize that. Okay. Find the constant of proportionality for each proportional relationship. So our proportional relationships we said were A, D, and E. Well, constant of proportionality is the same thing as rate. So if the rate for A was 4, the constant of proportionality is going to be 4. D. D was also proportional because it went through the origin. Okay, well D, we said the rate was 1/2. Well, if the rate is 1/2, constant of proportionality is the same exact thing, and so it's going to be 1/2. E is the last one that's proportional because it goes through the origin. E, we said the rate was 1/7, which means so is the constant of proportionality. Write a function rule for each proportional relationship. Well, we've got A, D, and E are proportional. Again, A, D, and E. A, D, and E because they all go through the origin. Well, we know in a proportional relationship, it's always Y equals something X. In a proportional relationship, it doesn't have that plus or minus at the end. Do you remember from class what goes in this box? Good job, it's the rate. So set it up, Y equals some box X, Y equals some box X, Y equals some box X. Now A, we found the constant of proportionality, or the rate, to be 4. So it's Y equals 4X. D equals Y equals 1/2 X. And E, we found the rate to be 1/7, so Y equals 1/7 X. Easy as that. All right, what do we have on the next page? Ruth's job at the Screen Pea plant is to inspect flat screen TVs for defects. She has 253 TVs to inspect today. Of the 46 she's inspected so far, only 2 have defects. Assume the defect rate remains constant and complete the table. Well, we know this is X and we know this is Y. So first thing we need to do is find the rate or the constant of proportionality, which means the same thing. It's the change in Y over the change in X. Well, we know that it's proportional. If it's proportional, we can just use this Y and this X. This Y is 2. This X is 46. And so 2 divided by 46 is, let's see, if we had to do it, we could reduce it to 1/23 or 0.0434782. So here's the thing. We can either do it divide by 23 or we can multiply by 0.0434. So let's do it the easy way and divide by 23. So all we have to do is divide by 23 each time. So 115 divided by 23 equals, I'm sorry, multiply. My fault. So here's what we have to do. To get to, wait, did I do that wrong? I'm sorry. To get from x to y, no, that's right. To get from x to y, we have to divide by 23. To get from x to y, we have to divide by 23. So 115 divided by 23 equals 5. Now here's the only one with a number on top, so let's go ahead and do that. Divide by 23 to go this way. 253 divided by 23 equals 11. Now, if we have to do divide by 23 to go from top to bottom, what do you think we have to do to go to from bottom to top? Good. When we're looking for the y, we divide by the constant. So when we're looking, let's make a note, when we are looking for y, you divide by k, or that rate. Okay? When you're looking for x, you multiply. So here we're looking for x, so let's multiply by that. 6 times 23, you get 138. This one, we're looking for x, so we're going to multiply. 7 times 23 equals 161. So again, let's take a note and just take a side note of that. When it's proportional, if you're looking for y, divide by that rate. When you're looking for x, you multiply by that rate. Okay, trial and error will also get you there. So write a function rule relating the number of TVs inspected to the number of TVs with defects. So remember, it's always y equals some number x. So to get y equals, we have to take x, we have to take the x, and we have to divide it by 23. So we can't actually do this. So we can do y equals 1/23 x. 1/23 times x is the same thing as x divided by 23. So take a moment, and now that's a little new, so take a moment before you start the second one and really let that sink in, or maybe listen to it again.